All right, question number 7 wants us to determine whether the graph or the function has symmetry about the x-axis, y-axis, or the origin. So recall property of symmetry. I'm going to write down the original equation. F of x is equal to x to the 6th minus 4x to the 4th minus 13. All right, so there's three things we're going to check. We're going to have f of x. We're going to find f of negative x, negative in the parentheses, and then we're going to look for negative f of x, so the negative on the outside. Okay, and so what that means, we're going to take our original equation. We're going to replace x with a negative x, still raised to the 6th, and then this is a minus 4, and then x negative raised to the 4th minus 13. All right, so the way we simplify this, anything raised to a power, we're going to raise it to that power. So if we multiply an even number of negatives, it changes back positive. So we're doing x to the 6th, and we're doing 6 negatives, which makes it positive because they all negative times a negative is a positive. They all cancel out. So this ends up being x to the 6th. All right, so the minus 4 isn't affected as a coefficient, but we're going to do x to the 4th, or negative x to the 4th, and again, an even number of negatives comes out positive, so this will still be minus x to the 4th, and the 13 is not affected by x. It doesn't have a variable attached, so still minus 13. So simplified f negative x is equal to this expression here. All right, and then we're going to do it with the negative on the outside. So just going to put a negative on the outside, and you're going to just multiply this whole expression times a negative. All right, so when I multiply by a negative, this gives me a negative x to the 6th. Negative times a negative is a positive, so a positive 4x to the 4th. Negative times a negative is a positive, so plus 13. So negative f of x is equal to this expression here. Okay, so now the properties of symmetry, these are the things we want to check. We're going to see if the original f of x function gives you the same function as f of negative x. This tells you even or y-axis. Okay, the way you think about that, if you had a graph and I went from a positive x value to a negative x value, that flipped across the y-axis. Okay, so that's y-axis symmetry, which is also known as even. So here's my original f of x. Here's my f of negative x. When I compare the function, I got a positive x to the 6th, a negative x to the 4th, minus 13. The whole equation equals. So we do have y-axis symmetry. Now we're going to check f of x and see how that compares to negative f of x. So that's this other one that we just made. So when we compare the top function to this bottom function, right away we see different signs. This is positive, this is negative. Although the term is the same, the coefficient is not. This is positive and this is negative. So these are not the same. This refers to x-axis symmetry. So again, think about f of x, that is the same thing as y value. So if you had a graph and you had a positive y value and it flipped to negative, it went across the x-axis, and those don't match, so we do not have x-axis symmetry. And lastly, we compare these two together. So f negative x, does that equal negative f of x? And we can see that these two are not the same, and so we do not have origin symmetry. So this one only has y-axis.